Thanks for attending my talk. My name is Daiki Hashimoto, George University of Education. The title is Pitch Peak and Word Predictability Results from CSJ corpus. The aim of this talk is to explore whether probability reduction can be extended to pitch values. More specifically, I will examine whether the pitch peak value of a word is affected by the information content carried by that word. The content of this talk is shown here, and this corresponds with that of the conference paper. So please read my conference paper while listening to this presentation. Okay, so first of all, I'd like to talk about what speech reduction is. The previous literature has shown that the phonetic realization of a word is affected by the contextual predictability. So for example, a word with higher contextual predictability given an adjacent word is produced with shorter duration. So for example, the duration of pepper may be shorter given a predictive context like salt and. This is because salt and pepper is a kind of fixed phrase. So that's why given salt and, the occurrence of pepper is more predictable. So that's why the pepper is likely to be produced with shorter duration. But on the other hand, the context like pass me. So in this context, pepper may be produced with longer, like pepper. So this is because after the pass me, so lots of words can occur like pass me scissors or pass me salt or something like this. So that's why. So the pepper is less predictive and it's more likely to be produced with longer duration. This phonetic reduction of a word as a function of contextual predictability is known as probability reduction. So this phenomenon has been discussed mainly in relation to word duration and occasionally with regards to formant values. To the best of my knowledge, this phenomenon has not been discussed with respect to pitch values in natural speech. So it remains unknown whether a pitch value is affected by the contextual predictability in natural speech. So I'd like to fill this gap, and this allows us to increase our understanding of how a speaker balances the accuracy and the efficiency in communication more in general. So the research question this study addresses is this. Is the pitch value of a word affected by the contextual predictability? So this research question is addressed in what follows. Let's deduce a specific prediction with regards to the research question. Although there are several frameworks in relation to probability reduction, this paper employs the theoretical framework called message-oriented phonology, MOP. So for the detail, please read the conference paper and Ho et al. 2016. In this theory, speakers are hypothesized to aim to create an effective message transmission by balancing resource cost and message transmission accuracy. So let's see these two signals. So one signal has longer duration, so redundant, and one signal has shorter duration, so this is less redundant. This redundant signal results in higher accuracy because the redundant signal is more intelligible. But simultaneously, this results in lower efficiency because the speakers has to pay more resource cost to the phonetic signal. On the other hand, a reduced signal decreases the accuracy because the reduced signal is less intelligible. But simultaneously, this results in higher efficiency. So speakers are hypothesized to obey the two biases. So one bias is to maximize accuracy, and the other bias is to minimize resource cost. And a message with higher predictability is not so important as that with lower predictability. This is because a predictable message can be reconstructed from the context. So taken together, so this framework can account for the probability reduction. A message with higher predictability is likely to be produced with a reduced signal, thereby improving the efficiency of communication. So my prediction is that this trade-off may be extended to pitch value. So the key hypothesis is that the intelligibility of a word may also be improved by raising the pitch value. So it's known that we are more sensitive to a higher pitch in relation to the pitch ranges used in human speech. And it can also be hypothesized that raising the pitch value incurs higher resource cost due to the articulate effort. So this is because the speaker is required to construct her vocal fold further in order to increase the rate of the vibration in the glottis. So maybe this kind of trade-off should be observed in human speech in the same way as the duration of a word. Taken together, we will test this prediction. A word with lower predictability may be produced with a higher pitch peak value, so that the message transmission accuracy may be improved. So I expect that this kind of relationship will be observed. So a word with less predictability is produced with a higher pitch peak value. And as for the relationship between the predictability and the information content, it will be discussed in the next section. Okay, so let's move on to the section about methodology. The current study employs corpus of spontaneous Japanese called CSJ to address the research question. CSJ core contains wave files and annotated text script files. So if I open these files using PRAD, something like this appears on the screen. The text script files include lots of information. So for example, word tier, and the segmental tier, and the international phrase tier, and the utterance tier. The current study uses speeches classified into academic presentation and simulated public speech. And I transformed corpus data into a CSV file in relation to this information. And the current study only focuses on the tokens that appeared at the international phrase initial position. So this is because depending on the location within the international phrase, the pitch peak value of a word is differs. So that's why I decided. So just to use 54,845 tokens occurring at the international phrase initial position. So using R, I also collect the other information like information theoretic measures. In relation to each numeric variable, so if a data point is 3 standard deviations away from the mean, so then it was removed from the data set. So at the end, about 54,000 tokens were explored in this research. And I also standardized numeric variables by subtracting each data point minus mean value. As noted in the research question, the response variable is the pitch value of a word. And I decided to take a peak value of a pitch. This is because if I get a mean value of a pitch, maybe it's affected by the length of a word. So that's why I decided to take the peak value of a pitch. And the distribution is shown here. And the distribution looks quite nice. And the mean value is about 216 Hz. And as noted in the last slide, I didn't standardize the response variable. So I just standardize the predictors as numeric variables. Variables of interest are the contextual predictability of the word given the adjacent word. So for example, a probability of a word given the preceding word, and the probability of a word given the following word. Following previous literature, I transformed the raw probability into information content by taking negative log base 2 of raw probability. The formula are shown here. I just want to note that raw probability and the information content negatively correlate. So this means that this y-axis indicates information content and x-axis indicates raw probability. And a word with higher information content has lower probability, lower contextual predictability here. But on the other hand, a word with lower information content has higher probability, higher contextual probability. And I treat these two types of information theoretic variables as PLEC IC and fold IC. Obviously, a pitch peak value is affected by a variety of factors. So for example, a pitch peak value may be affected by word frequency and gender, and the speech type, and the speech rate, and the lexical accent. So that's why I decided to fit these variables as control variables alongside with the variables of my interest in the statistical model. So for detail, please see Table 1 in the preceding paper. So now I'd like to report about the statistical result. About 54,000 international phrase initial word tokens were hand-fitted into mixed effect linear regression model. This analysis was performed using the LME4 library. And as noted in the last section, the 7 fixed effects were fitted into a model. And this is the model formula. And this model includes by speaker and by word random intercepts. And it also includes by word and by speaker random slopes for the variables of my interest. So this is the model summary of the best fitted model. And the same table is provided in Table 2 of the preceding paper. And note that the reference label is set as gender female, speech academic, and accented no. So this means that the intercept means that the pitch value is about 257 Hz when the speaker is female and the speech is academic and the word is lexically unaccented, and the 4 numeric variables are 0. So this is the 4 numeric variables are 0. So this is because I standardized all the predictors of numeric variables, so that's why. And this is the interpretation of the numeric variable as an example. So the pitch peak value is expected to decrease by 1.77 for every 1 unit increase in word frequency. And this is an example of the interpretation of a binary variable. The pitch peak value is expected to be 77.883 Hz lower in male speech as compared with female speech. So now let's discuss the variables of interest, so the information content given preceding word and given the following word. So as for the effect of preceding IC, this is shown using scatter plot. X-axis indicates the value of the preceding IC, and the Y-axis indicates the pitch peak value. So from this figure, we can find out that higher information content, the pitch peak value is likely to be higher. And as for the following IC, so this is also shown in the same way as the preceding IC, and a higher following IC results in lower pitch peak value. At the end, let's summarize this study. So in this study, I explored 2 types of contextual predictability which are converted into the information content. And as for this type of information content, the effect was totally as predicted. So this finding can be captured by positing the effective message transmission, so the balancing the accuracy and resource cost. On the other hand, the effect of following IC went in the opposite direction than predicted. So this observation may be a little difficult to capture. The current study has only explored a word at the beginning of the international phrase. So this may be the reason. And I'd like to consider non-IP initial words in the future study because I already collected the whole dataset from CSJ. So this is not so difficult and I'd like to do it in the future. But anyway, the current study suggests that probability reduction is observed widely in human speech. So previous literature explored word duration and formal values, and this study found that the pitch peak value of a word is also affected by the information content of the word in a way. This is just a small question to anonymous reviewer. Thank you so much.